All right. Hello. Test. If somebody on the channel could confirm that we got audio.
Somebody tell us, can you hear us on the YouTube channel? Brett, can you hear us?
Nothing yet, really, but I'm not sure if we're supposed to hear anything. So, it's
now,
good. Okay, now it's coming. Yep, I can hear Maxim.
Excellent. Was it just delayed?
Oh, it's always
All
delayed.
right.
Take it away, Alex.
Okay.
Hello.
Well, ladies and gentlemen, thank you for joining us again. We're halfway through the OpenSIPS Summit 2020 distributed. Last 2 days have brought us some amazing topics. We had some great talks about the status of what's going on in the OpenSIPS VoIP world. I'm not the OpenSIPS, but the open source VoIP world. Both core developers from OpenSIPS, Liviu and Vlad, gave us some great look at some of the new stuff that's in there. Today, we're going to be going to Mr. Maksym Sobolyev. He is the head guy over there at Sippy Labs, and he's going to be talking to us about RTPProxy, OpenSIPIt, and MicroSippy. And just as we are mentioning Maxim, I want to thank him again for doing an amazing job getting this all broadcasted and connected to all of you. So without much further ado, Maxim, take us away. Maxim?
Oh yeah, thanks, Alex. Let me just give me a second. I'll set up screens. Yes, Alex mentioned also handling the AV part here. So I need to start my presentation.
While Max is getting started, I want to remind everybody that we're doing another raffle today. We are going to be raffling off at the end of the day. So make sure that you're sitting inside the Summit raffle channel, because that's on Slack, because that's the only way you're going to get a chance to win.
Yeah, and because it came to the raffle on Friday, we have the special prizes, because Friday will be the last day, conference day, and the big prizes are reserved for Friday, so don't miss that day.
We're still working on a date with Bogdan. How we doing, Max? Well, look at that. Ladies and gentlemen, Maksym Sobolyev.
Almost there. Just give me 1 second.
No pressure. No pressure.
Little magic trick. Is anyone?
Almost there. Please wait. We're buffering. We're buffering.
Got a presentation. Now I need to get.
You know, he did it so nice for everybody else so far. But, you know, when you do it for yourself.
Yeah, it's always tricky. I need to fix myself.
I think this is part of the presentation, just to increase the tension before the actual presentation, so everybody's like, you know, ready to jump.
They understand how much work goes into it.
We have a saying
okay, I got it.
that in the heart of the all the shoes are broken.
Giovanni, you have massive echo.
Yeah. Okay, I'll try to fix it.
Max, you ready?
Almost.
You look like you were waiting. Sorry.
Yeah, I'm waiting for trying to put my face on the slide, and it's not responding here. All right. Yes, I'll switch to the backup plan.
No, the golden rule is do not force it. Just use a bigger hammer.
Yeah. All right. I guess that's as far as it goes. So hello everyone. My name is, has been said, is Maxim Sobolyev. I'm first. I'll give a little bit since I know there are a lot of people in this room who probably have not met me at the OpenSIPS Summit. I'll give you a little bit of introduction who I am. So born and raised in Dnipropetrovsk, back then USSR. About 15 years ago, I moved to Vancouver, British Columbia, Canada. I have a master's degree in physics and radio physics from Kyiv State University. And I was always, since I was a kid, I was always between kind of computers and science. So it's basically to the interest that that I still pursuing in some form. I got involved into open source movement in my late years in the university. I discovered FreeBSD, and I was just curious about Unixes and operating systems in general. So I got involved as a user first, and then started submitting patches, fixes, and so on. So eventually joined the project, and I'm still one of the developers to date. I think FreeBSD, it's not very well publicized, but it's one of the biggest open source projects, organized open source projects right now. So there's like 400 active developers working on the code, and yeah, so that's kind of some background on myself. Then why I'm here exactly? It started with in 2003 when I got a new job. First my job in computer and telecommunication industry after finishing school. And we've been trying to implement some SIP switching functionality into existing Billion platform. So as part of the job, I was started investigating. SIP was just fresh out of IEFT. I think it's they approved in 2002 into RFC. So basically, at that point of time, there was not only like probably 2 or 3 projects who implemented SIP in one form or another. So as I said, I was pretty excited about open source and its uses in the industry. So we started looking at open source implementation. I got discovered SIP Express router, which was at some early versions, but still the kind of the core of functionality was there. So, and as I said, since it was in early stages, there are a lot of functionality which we take for granted these days was either missing or in very early stages of development. So one of the obvious things was absence of any NAT traversal support, which was kind of one of the biggest issues of on the list because it's not really covered by RFC. So we basically started looking at what could we do to make SIP work good with the NAT and all that. It basically ended up with creating our own module, which we called NAT helper, and contributed it shortly to the SIP Express router. And then we also discovered that in some scenarios we could not handle not 100% of the time without some kind of support on the RTP side. So we basically prototyped RTPProxy and again contributed as open source. And at some point of time, it was even part of SIP Express router CVS repository.
Maxim, do you remember the story after the RTP proxy, was made public? I think in terms of months or maybe 1 year after that, there was the the whole story with the media proxy released by the AG project. And I remember it was a kind of a funny situation because Adrian just announced it and he keep saying, okay, the media proxy is better, and everybody was asking why. I mean, what's different? And it was like, no, it's just better. And it was this kind of a stupid back and forth, like, okay, he was saying it's better, everybody was asking why. And after some time, I think I'm not sure who discovered, or it was admitted that the only difference actually was, okay, I think they were doing also relaying for the RTCP packages, not only RTP or something like that. No, but they were keep hiding, and they're just saying, okay, this is better. And I remember that was a kind of a small, firestorm on the mailing list at that point. Like, what? Really? Tell us, what's the difference? But yeah, I still remember that.
Yeah, it was a little bit of that. And also, I think we got a little bit of squabble, I would say it, with Adrian about the fact that they used a lot of code from RTPProxy module in SOR to implement media proxy module, but they did not put copyright notice, and I got a little bit upset by that. not so much about what the difference is. But anyway,
what you're saying is that squabble was a gentle euphemism.
yeah, well, I met Adrian a few times since then, and I think we're both kind of pretty relaxed about it. So now it's more like a fun story to tell, right?
Yeah, no, exactly. I mentioned it more like, I mean, it happened like 15 years ago, but yeah, looking back just to see the whole story behind all the struggles with all the open source code and different kind of approaches, versions, and so on and so on and so on. Yeah, sometimes it's not funny, but I would say, yeah, it's interesting.
Enough stirring the pot. Let the man get back to his presentation.
Yeah, so thank you, Bogdan. Actually, it was pretty fun to remember that. But anyway, we kind of our own approach to the open source is basically whenever we're practical people, so we try to implement practical things here using open source software. And whenever we find something that is could be improved or in a good way change that software, we try to contribute it back. So essentially that kind of continues in 2009. I think we were first. We started working on this module actually earlier. I think it was in 2007, 2008. Since we also implemented Python B2BA, we found it's very very compelling that we could use some of the Python code from our SIP Express router configuration script. And so that's kind of ended up with us creating a Python, which we then contributed back to OpenSIPS first and Camellia a year later. And it's been I don't know, we did not have much presentations about it in OpenSIPS side, but I heard a lot of people using it on Camellia side of things. So it was definitely good good idea as well, even though it's not very kind of, we don't bang it too much. But anyway, it's streamlining to today's more closer to today date. We've been also pretty since we discovered our first OpenSIPS meeting, I think in 2016. Oops, sorry, some echo. We went for it was in Texas, one of the I think the only US event to date, unfortunately, but we'll hope it changes someday. We kind of loved it, and we discovered there is a lot of good people and very active community. So we found we met Alex, obviously, and it's been amazing since then. But we also met a lot of other people in the coming years. So yeah, it was very interesting, and we tried to participate it and help to build this community even bigger, doing online streams from about 2017 from Amsterdam. And yeah, we're still trying to be involved in ongoing work with especially questions related to RTPProxy or not helper. So, and if we find something not working, we will try to report it, and at least if nothing else. Sometimes it might be just easier to fix it and submit a patch. So anyway, that's kind of a little bit of story of our involvement with OpenSIPS and its community. On the other end, in those years, what else we have done? I organized, after working for a few years for different companies in this field, I organized my own SIP software business in 2016. I don't know, keeps me busy ever since. We're growing steadily, but at least it goes up, so I'm pretty happy about that. We also do a little bit of, since 2015, we also do a lot of work in the background by building some CI integration tests, which helps us to track any deficiencies or any new issues introduced in latest OpenSIPS versions or Camellia or B2BA. I can probably just give a brief overview. Let's see if I can switch my screen. You guys see, right? Presentation. So this is our VoIP test projects. Zoom in.
Just a little.
Yeah, and basically here we have a set of about 30 scenarios, which we then run through different combinations of Camellia, OpenSIPS, Sippy B2BA, and try to see if there are any problems with the call flow. It works pretty well. As I said, we've been. Sorry, I did not switch my tab. So basically, there are some nice diagram here. What it does, and basically we put those different versions and test them against different versions of RTPProxy, making sure that nothing gets horribly broken. And whenever something comes up, we try to report. And it turns out this kind of setup is very helpful in actually tracking those problems more deeply. So here you see, for example, instead of doing like different versions of different product, we just stack up different revisions of OpenSIPS code, and it basically pinpoints us when the regression was made. So we only test every day for the main branch, but whenever a problem comes up, we can basically easily, or relatively easily, with the help of Travis, to narrow down to specific commit which broke things. But anyway, that's side note. Let me just switch back to my presentation. All right. So that now more to the point of this presentation, or to the main topics of this presentation. First, I have several, at least 3 topics to cover. So we'll probably give people a little time to ask questions after each section. So in order to get started with the first section, I'll play 2 short video clips and ask people to at least think what the difference, important difference might be between those 2 systems, or post it on the chat would be interesting too, and I'll give you my answer after that. So this is the first clip.
Good evening, Dave.
How you doing, Hal?
Everything's running smoothly, and you?
Oh, not too bad.
Have you been doing some more work?
A few sketches.
May I see them?
Sure.
That's a very nice rendering, Dave. I think you've improved a great deal. Can you hold it a bit closer?
Anyway, and the second clip is this.
Hey Google, what is OpenSIPS?
According to Wikipedia, Camelio, formerly OpenSR, is a SIP server licensed.
Anyway, so obviously the answer is stupid, but apart from that, what do you think is the difference, and how we can possibly make it better? I'll give probably viewers 15 seconds to think. All right, now my answer to this is, well, it is Space Odyssey 2001, so it was before SIP 2.0, but probably it's feasible to think that SIP was already, SIP 1.1, which is RFC 2533, was already around. So if I were to implement this real-time communication system, I would probably use SIP, and then you can basically, as soon as you can view it as having like whole 9000 backend somewhere in the trunk of that spaceship, and there are a lot of UAs all around, those cameras, speakers, and so on. And so it's pretty feasible to have real-time communication between Dave and Hal in that scenario. Whereas if we look at the what been implemented these days, it's all HTTP based. So basically we have this Google UA, which is Google Home in my case, which collects recording and then posts it to the whatever Google AI backend, how you call it, waited to process it and send back the response, which then played back. So it's all very non-real time and very clunky in my view. So that's kind of background for why we wanted to do like very small implementation of SIP, which we call Microsippy. And it also, if you look into this a little bit deeper, again, I don't know how many viewers are familiar with how this integration with the AIs is done these days, but usually you get your where is the pointer? There is pointer. You get your speech, you then do some framing, and you basically convert it into frequency domain, and then you feed it into the recursive neural network for further processing. And if we've put like SIP into this picture, you see there is pretty much the same thing going on with the codecs. In order to send audio over network, you usually apply some kind of codec which essentially does the same thing. It basically takes your speech and which is time domain signal and converts it into frequency domain, which we call G729 or whatever codec you might like. So essentially, apart from the real-time scene, it might also allow doing something like this, where you can basically encode your stream on the client and send it over network, and then feed directly to your AI without decoding first. But anyway, the whole point of this MicroSIPI project is to create small SIP implementation, and by small I mean really small as it can run on anything pretty much which has at least some processing power. We use a lot of experience building our B2B, and obviously working with OpenSIPS gave us or NCR for a long time gave us a lot of knowledge on how to create we hope good SIP stacks. So basically this project is very quite early stages of development, but we got some promising results. So we have from what we see very quick SIP parser and tokenizer. I'll show you some numbers maybe, but we also managed to put the whole parse structure into one buffer with the SIP message itself. So essentially, you have only one allocation for the whole parsing stage, and it's very easy to basically get rid of it. Because if you look at the existing codecs, sorry, not codecs, SIP implementation, even small ones, it's basically done with kind of bunch of mallocs. So you have one structure which has a lot of smaller structures, and managing it would takes a lot of time on smaller system, because even something small as calling function takes significant chunk of time in real time terms. Anyway, some of the results we got, we're about 2 2 millisecond SIP parse time at a very small microcontroller like this. I don't know if you guys can see it, but it's this ESP8266. It's not the latest. The newest has 2 cores, but this is just 1 core. And the idea is that you probably want to be able to do like SIP interaction quick enough so you can handle your RTP stream, which is 100 packets per second. So you have 10 milliseconds between packets to do other stuff. Well, not 10 because some of the time will obviously be spent on actual RTP processing. And also this code, we try to organize it in more or less platform independent way. We have 2 separate backends at this time. So we basically have this microcontroller backend, which is based on FreeRTOS, and also build POSIX into it, so we can have automatic runs on the Travis, and basically make sure we are not we remain compatible with even latest CPUs. Okay, I think I need to speed up a little bit. So yeah, there might be some other possible uses for this code. You can potentially look at it as kind of SIP accelerator for higher level language implementations. So we are definitely considering using this code at some point to make our Python SIP implementation more scalable. There might be some interest from the perspective of deep packet inspection on a desktop server class CPU. We can reach with single core. We can reach already 150,000 SIP packets per second parsing rate, and yeah. Might be some other uses. For example, as I mentioned, we pack everything parse structure and the SIP message itself very tightly, so it might be interesting to see if there could be potential uses for transaction serialization, because you can basically parse your message once and then distribute it between several entities and avoid parsing it again on each of them. But anyway, so the status of it, we were hoping to get something that can actually pass RTP this year, but we're still in progress. However, SIP parsing and tokenizer are good enough. It basically, I can just give a quick overview look at stuff. So this is actually what is running on this microcontroller you have, and it basically set up this way. So each time the vendor of the board pushes new version of FreeRTOS, it will build and run it here. But as you can see here, we parse pretty detailed. We do pretty detailed parsing, so it should be good enough for building higher level abstractions on top of it. The next step would be for us is to implement some of the transaction logic support. And again, if you guys get interested to do something cool, let us know definitely. For now, it's just me working on this code, and yeah, I have a lot of other stuff. So, and there are some other potential implementation which we see maybe a little bit later down the line. Some of them were, if you want to find more information, there was presentation 2 years ago in Amsterdam, which is available on OpenSIPS channel, which you can watch if you have not seen it already. Okay, so that's MicroSIPPy part, and yeah, if you guys have any questions, shout out on the chat. Try to answer it. In the meantime, I will move to the RTPProxy. As I mentioned before, it's yeah, the project been around for a long time. Unfortunately, one thing that we did not really manage to do over the years is to build some kind of community around it for some reason. Well, we got help from people, but it's probably some of our fault. So the things are not progressing as fast as we wanted to, but it's mainly because we have all other stuff to do. But nevertheless, since the last OpenSIPS summit in April or May last year, we did some work on that. And first, I would like to mention is the test coverage. We're basically pushing 91.5%, and that's across all the code. And it took us about 2 years to get to this point where we could basically exercise pretty much all the lines that matter in the code to build the test cases and all that. But that looks good. Then another thing that we are actively working on is plugin module interface. There will be some information from it, I think, on Razvan's talk later about some of the first modules that we had. But in general, we were trying to build some kind of generic interface for people to plug in the functionality, which would do some interesting stuff with RTP into separate modules, so we don't blow it up and and make the core of RTPProxy slower and more complicated. We also adapted the configuration parser, which is now used mainly for the configuration of those external modules. And we definitely would like to make it more all-encompassing to also allow parameters which are right now specified on the command line to be in the config file as well. But then for that module interface, we did quite interesting work, which Razvan is going to talk about last November. I think we implemented the ability for RTPProxy to capture DTMF and report it back to OpenSIPS. And I should give shout out to OpenSIPS guys, and it was very smooth and very kind of very good collaboration. And yeah, basically we also have full test case for these scenarios as well, so we basically have it all covered into the test scenarios. And then the HAP integration, we had it for a little longer than DTMF. I think it was added about year and a half ago, perhaps, which would also be included in 2.2 as a module. And apparently some people already using it. We got some bug reports when we broke it during development. So that's I think a lot of people might look into that. Then since the last summit, I got some help from from some community members which I met on OpenSIPS Summit with building up a little bit of online documentation for the RTPProxy, covering some of the scenarios, deployment, system integration, and so on. And the last big item, I think, is the implementation of the link time optimization, which I done about 2 to 3 months ago, which I think all pushed into the RTPProxy master and will be available in in the next release shortly. And for those who don't know, link time optimization is basically more high-level optimization mechanism where you can optimize compiled code, because in the original Unix approach, you compile your code into object file, and that's already like unit in itself. You cannot optimize it further. But with the link time optimization, your code, your source code, C code, is compiled into intermediate optimization, saved into object file, and only at the linking stage, the compiler or linker, in this sense, but it's pretty much the same, will do optimization by pulling functions from different modules and combining them for better performance. So I think that's all updates I have on RTPProxy and of things. I think we have a question from Stas Kabzar. He asks, I joined a little earlier. If you ask something you were saying already, but did you consider using lexers like RE2C or Ragil state machine for partition SIP? That's a very good question. Thanks, Stas. Well, I have not really looked into those particular approaches for parsing SIP code in general, and maybe that's something I should do. However, I looked into like bare SIP and those smaller implementation, PG SIP and so on, and those seems they suffer a little bit of that syndrome where you kind of expect, for example, things like STR to work well, but on the smaller system, even like things like finding the end of the string is not trivial if you look at it, because if you just do str for those 2 characters, it will kill your performance right away, because essentially 2 milliseconds that I mentioned before, it's about the times that you have average function. You can call average function for like str or something only like 30 or 40 times. So if you need like 20 calls to just to identify the ends of the string, that would pretty much end of game for this. But with a little bit clever of bit magic, you can basically do very, very interesting stuff. But yeah, I don't think we have time to go too deeply into this. But in any case, if you have any particular suggestions or experiences, please follow up. So I guess that's all for the questions on this one, and I'll move to OpenSIPIt thing. So what is OpenSIPIt and what we want to achieve with it? For those who've been around for at least I would say 7 years or 10 years, you might still remember this event. It was called SIPIt, and they did a pretty good job in the early days of SIP by bringing several independent implementation together from the industry and having them to run tests of various SIP scenarios between those implementations, and then identify any issues or any problems or anything pretty much, and hopefully get it fixed sooner. They even at some point gave some feedback to the RFCs, groups working on new RFCs, as to what needs to be improved or fixed. But regardless of that, that was a good job. But there are a few things that we kind of did not like as much. The fact that it was pretty difficult to get into without like big pockets and stuff like that. So for the first 10 years of our existence, we only kind of looked at it and was hoping that someday we could actually participate, which the DTMF actually have as their badge of honor. It was SIPPIt 32. I think it was unfortunately the last one they did. It was held in University of New Hampshire, and they have very big and very well equipped interoperability laboratory. Although we did not use obviously much of it, we just used internet, but they gave us a little tour, and it's apparently very big in the industry. All those anything like any electrical things or anything that gets produced in any considerable amount gets extensively tested. But anyway, go back to OpenSIPIt. Since we really like that idea, and we really hoped we would follow up with it, but for the reasons that are beyond our control, they just stopped after number 32. And over the years, I spoke to some of the people who organized it, and we did not get much traction in getting it restored or resumed. So as our approach, if we cannot get Vault to do something that we want, we do it ourselves. And that's kind of the idea about OpenSIPIt. Differently, we want to do it a little bit, spin it a little bit differently compared to original SIPIt. We want to be it fully open source, or at least as fully as we can, fully open source based events. So we at least expect that all people who participate use open source implementations, which would allow us to hopefully fix and resolve bugs right on the spot or very shortly. It would also hopefully let us build some of the tools and share configuration with the broader community, because as the last step of this event, we hope teams will push the configuration to the public repository, so all people can look at it. And as I said, we want it to be as open and accessible as possible. So we're basically, you don't need to have like big corporation backing your implementation or your SIP whatever to participate. And last but not least, we hope to get everything streamed on YouTube in real time. So we at least hope will be fun, not only to participate but also to watch. Again, we're running out of time, so I'll just go skip all those slides and faster pace. So we hope at least at some point to test extensively some of those rarely used scenarios, and maybe also put implementations into little bit harsh environment, like simulate packet loss and high latency, put some memory shortage constraints and so on. Because in my experience working on RTPProxy tests, there are a lot of bugs hiding in those never exercised or rarely exercised code paths, because you call malloc and you assume you get something. Even if you have a check in the code and it looks okay, it might not work very well in the practice. So the idea basically is to run everything on AWS EC2 cloud. There is no particular reason to pick this cloud apart from the fact that it's probably the longest cloud in existence, so it's the most advanced in our view, and people, at least majority of the people had participating in the event will have some experience with it. So each team will get its own instance, and will set up network between those instances and run our tests. At some point, again, I'm not sure if it will be done for this first version. We would like to have some kind of advanced nighting scenarios as well, but at the very least, it will be network between the participants. So yeah, for this event, we already agreed with lot of, well, considerably good amount of projects which represent quite big share of SIP protocol users in open source world. So thank you, OpenSIPS first. They've been amazing with the support and all that, and hopefully we'll have them participate actively next week. Free Switch, our own team. Then we will have Dractio, Camelio, and also interesting thing that we got interest from SIP Vicious, which is enable security guys, Sandro and his colleague Alfred, I think, who will also be participating, and hopefully will shoot us with some nasty traffic and see how it goes. Anyway, we only have 2 minutes left, so basically the focus for this event will be SIP push notification tests, the amazing work that Liviu done in OpenSIPS recently. We also want to have at least some amount of testing for the new SIP digest authentication RFC updates, which is 8760, which finally puts some non-obsolete digest into SIP authentication schemes, and the thing that everybody loves and hates, stir shaken, which we still don't have much of the understanding about what can we test. But anyway, it will be very dynamic, and we'll figure something out. I mean, with all those people in the room, I mean, it just could not go bad. So yeah, that's about it for my update. I hope I did not bore you guys or put you to sleep, because we have a few more pretty amazing presentation today, and there are some contacts. I'm available on the chats. Yeah, if any questions, let me know. And thank you.
I have a question about MicroSIPY.
Sure.
Maxim, have you tried the MicroSIPY on many platforms like ARM-based? How did you? How are you testing that right now? You are playing with Raspberry Pis with?
No. As I said, I have this microcontroller on my. I don't know if you can see it.
Which
is like this.
Okay, so it's an ARM-based one.
No. It's not an ARM. It's its own processor. It's called ESP8266, I think. And it's basically sort of hybrid between microcontroller and real processor, so to speak. So it's smaller than the ARM, but a little bit bigger than like Atmel and all those low level chips. But it runs RTOS. So what I do, I basically hook it up to Jenkins, and there's a lot of unrelated builds. But it basically it runs on the virtual. The Linux runs on my virtual machine here, and this board plugs into that virtual machine, and that virtual machine builds the code, uploads it, and then shoots some SIP messages back and forth between the host and this little guy here.
So you're kind of like of porting some of the open source projects you have built until now. So what are you running right now on the RTOS?
Oh, it's just RTOS. The way RTOS works, Vasilias, is basically you build your application. It's like monolithic application. You don't really run applications. So you basically you take your RTOS, you put your code in it, and you build into one binary, and then you push it to your microcontroller.
I had an experience with an AVR32 Atmel based 10 years ago, so I really understand the core the core of that. So the project is great, and I think it has potential in the IoT industry. It can run anywhere. And
yeah, well, that's the idea. Yeah, that's the idea. Make because if you look at the fridge or your car or anything, it does a lot of things. I mean, it won't be able to, you know, put everything for SIP, like all resources. So your SIP should be as small as unintrusive to the whole application as possible, and that's something that I want to achieve with this MicroSIPY project.
Okay.
Awesome. Do we have any other questions out there? Light them up.
All right, I think we're good. I mean, if, as I said, if you guys have any questions.
I have a question.
Sure.
When is RTPProxy 2.2 going to be released?
Well, I wanted to do it yesterday, but then I went on to slides. So I'll try to push it today, at least the branch. Yeah, it's always like this. I mean, I still have some tests that I wanted to fix, but yeah, I'll try to push it 2.2. Yeah, later today.
Take it easy, Max. No pressure. No pressure.
No, put pressure on me. Otherwise, nothing is done.
But I heard that there is some plugin architecture, and some plugin is almost ready, and maybe someone will speak about in the next presentation.
It's possible. It's possible. Well, it doesn't
right.
look like we have any further questions. Hey, Max, thank you so much. That was awesome.
Thank you, Max.
Maxim Sobolyev, everyone.
Thank you, guys. Thank you, guys.
So I'm going to just take this moment real quick to remind everybody that, once again, we have another raffle today. We'll be giving away one of these amazing OpenSIPS 2020 Summit t-shirts. Wow. Giovanni, what broad shoulders. And I believe today's prize is going to be another hour with the OpenSIPS core team, where you'll get to completely isolate them, get them to yourself, and at that point you can choose to talk about your wildest dreams or just stare at each other. Our next presenter comes to us all the way from the OpenSIPS core team again. We have Razvan Crainea. He will be presenting to us DTMF Handling in OpenSIPS 3.1. He's got a presentation and a demo for us. So this is going to be really fun. Razvan, take it away.
I hope so. Do you see my shared screen?
We do.
Perfect.
If you give me a second, I was wondering it.
Sure. So first of all, I would like to thank Alex for the nice introduction that he's always doing for all of us. Thank you, Alex. And I would also like to thank Max for this handling this awesome conference. And not only that, you'll see throughout my presentation that he deserves a lot of credit for the things he's done up until now. But yeah, we'll all see.
How we doing, Max?
A little bit
Good?
of suspense.
Shaking his head, yes.
Yep, you're muted. You're still muted, Max.
Where's that mute button?
Sorry, I got lost in the screens. Yeah, you can go now.
Awesome. Thank you. I thought you only wanted to present yourself and just bail me out. Okay.
Bit easier on the eyes.
Okay, so today I will be talking about DTMF handling and how you can handle DTMFs in OpenSIPS 3.1. I will talk about the two projects that we require or that work along with OpenSIPS in order to provide these DTMFs. I will show you a few use cases that I've used and a demo that is going to be hopefully quite interesting for you. So let's get started. First of all, what are DTMFs? DTMF is an acronym from dual tone multi-frequency signaling. So although the name is a bit cryptical, you can see the DTMF keys as the keys that you're asked to press when robots are asking you to do stuff during a call. This mostly happens in IVRs, the interactive voice responses. So it basically it appears basically when you call to a number, a robot's answered and asks you to do stuff like if you want to talk to speak English, press 1. If you want to speak Spanish, press 2. And the DTMF key is basically the key that you press. It has a limited char set, so the most commonly used are numbers, star, hash, and some dial pads have the A to D keys. There's also two ways of delivering DTMFs in VoIP, out of band and in band RTP. We will be talking about this a bit further. Out of band DTMF keys is out of band means out of the media stream. So if it's out of the media stream, they will basically go through SIP. So whenever you press a key on your dial pad, a SIP message will be sent to OpenSIPS or to the proxy or directly to the other user agent. And a 200 OK will probably come in saying that the key was received. There are two ways of doing this SIP-wise. One is the in-dialog request. So basically trigger an info message inside the dialog. That's RFC 2976. Or you can also use a presence mechanism where a phone registers for a specific event saying, hey, when Alice presses this key, notify me. This is RFC 2848, which is not that much used. In practice, I've never seen it being used, but it's there for legacy purposes. However, the in-dialog request is quite used RFC, and you've probably met it up before. All these out-of-band DTMF keys are basically encoded in a text payload and are part of the info or notify payload. So having them proxy through OpenSIPS gives you the entire possibility to read the body, check out what was the press key, and so forth and so on. So it gives you the flexibility to do the loads of actions on in the OpenSIPS side. For the in-band DTMFs, things are not that simple. Okay. Seems like my animation is a bit screwed here. Anyways, so for in-band DTMFs, basically the keys are sent in the media stream. So if you get Alice and Bob, although the dialog was established through OpenSIPS, so through a proxy, if you have Alice and Bob talking to each other through the RTP channel here, the DTMF keys will also be sent through this channel. This means that we, from OpenSIPS side, we don't have access to these keys. So in order to intercept them, we require a media relay. We require somebody to step in between the RTP flow and intercept the RTP traffic, decode it, and send it and inform OpenSIPS about the DTMFs that are flowing through this RTP flow. These media relays basically there are two projects that support DTMF detection. One of them is RTPProxy, and the other one is RTP Engine. And OpenSIPS 3.1 has support for intercepting DTMS for both media relays. In terms of encoding type, so the way the payload goes through the media relay, so the RTP, sorry, there are two types of encoding. One is audio tones, which is basically the key itself is encoded in a special sound that needs to be decoded. So you really need to take the RTP packet, decode it, in order to find out the DTMF. And later on, the named telephony events, the NTAs, RFC appeared in RFC 2833, and later that was later obsolete, but by 4733, which describes how an actual RTP packet should be constructed with a different payload type in order to easier detect these DTMF codes. Okay, let's see how each of these two engines use how they detect DTMFs and what how they are informing OpenSIPS about them. The first one that we are talking about is the RTP engine, which is developed by the Sippy company. It's basically started as an RTP media relay, which later got support for RTP to SRTP bridging. It also has support for audio transcoding, playing back medias, doing call recordings, and later on intercept DTMFs. RTP engine can also log the DTMFs in at the syslog, but it can also send them to a specific destination where somebody can intercept them. RTP engines had, up until now, had a quite interesting notification mechanism. So, for example, in order to tear down a call due to lack of RTP, one had to configure an XML RPC back-to-back callback that were triggered by the RTP engine. So if you would have set here RTP XML RPC request to OpenSIPS saying tear down this call, it would have gone through MI. So you'll have to load the MI XML RPC and G module in order to receive the notifications. Although this was a bit, let's not say complicated, it required some extra modules such as the MI XML RPC and G module. However, when they developed the DTMF keys notifications, so the notifications that were sent when the DTMF key was received, that was a completely different approach. So instead of having an XML RPC, which is basically a TCP request that contains an HTTP message with an XML payload, so it's quite it's not that straightforward. They would have developed a very lightweight method of delivering these DTMF keys simply by sending a datagram packet over UDP. So this is a bit this is way lightweight than using an XML RPC. However, the problem was that we didn't have any ways of intercepting these DTMF keys in OpenSIPS. So we had to develop a new interface that was able to intercept these DTMF keys and deliver them to the script. So the datagram packet is basically a simple JSON sent over UDP. So it wasn't that hard to decode the packet. So it wasn't such an, let's say, such a complicated job of decoding it. However, there was I will have to note the lack of documentation for this. So in order to develop all this feature, I had to do a lot of reverse engineering in RTP engine. It's not such a big problem because I like to read code, but I would love to have something documented so that that proves me that things will not change in the future. But anyways, it works, so we will have to work with it as it is. In terms of notifications, in terms of configurations, there both servers need to be configured. For example, in OpenSIPS, you'll have to set up a notification socket, which is basically the UDP listener that the notifications will be sent to. You will have to define an event route for the eRTP engine notification event. So basically, all these DTMF events will be sent through the event interface that we have in OpenSIPS that can be intercepted either in a route in OpenSIPS, in an event route, or can be passed further through the event interface. So you can have your own, for example, RabbitMQ listener that would receive the DTMF key, and you can process it in your own application. So there's no limitation of running it inside the OpenSIPS script, but you can do using the event route. For the RTP engine site configuration, you'll have to define, in the configuration file of RTP engine, you'll have to define the DTMF log dest parameter and point it to the notification socket you've defined in OpenSIPS. This brings not so nice limitation due to the fact that notifications will only be sent to a single OpenSIPS instance. So you can't have multiple instances of OpenSIPS running using the same RTP engine, because the DTMF logs will be sent to can only be sent to one specific instance. Of course, you can have some sort of proxies that can determine where the dialogues are and stuff like that, but it's not that straightforward. Also, a thing that I didn't realize or how to do, as I said, there was nothing documented, but you cannot filter whether you want to receive the DTMS only for specific calls. So currently, if you configure this parameter in RTP engine, you will receive all the DTMS for all the calls that are proxied through RTP engine. Again, I couldn't find any documentation of this. So if this is not true, please help me out and show me how I can do this, because it would be of interest for me. So as soon as a key was pressed on your keypad, on your dial pad, a DTMF event would be triggered by RTP engine, sent to OpenSIPS, and OpenSIPS will eventually run an event route for eRTP engine notification event. Probably I forgot to mention, although it was written on the slide here, the notifications that RTP engines triggers are generic. So currently only DTMFs are supported as far as I know, but other notifications will probably be developed in the future. That's why, as far as I could see, the notification event was basically split in two, where the generic fields are type, which indicate, for example, in our case is DTMF, but also have the call ID that generated the notification, the source tag, the timestamp when the key was generated, but also some DTMF notification specific fields such as source IP. So this indicates who's the source IP that generated the DTMF. This is the event, basically it's the key that was pressed, the duration, how long the key was pressed, and the volume. This is something related to, it's probably inherited from the old audio codes, because I'm not sure how volume could affect or could be, how you could issue a different volume. And that's it. That's all you have to do. But let's go further and see how RTPProxy does it. Not sure how many of you use RTPProxy. but you've probably already learned that RTPProxy was developed by Maxim. You should know him already. So let's give all the credits he deserves. Thank you, Maxim, for providing us RTPProxy and lots of other stuff in the VoIP industry.
Thank you.
You're very much welcome. RTPProxy was developed in 2003 and also started as an RTP media relay. But throughout the years, he developed other functionalities such as playback media, also forking a media to a different destination. And this is quite interesting because we are doing a lot of applications with this feature. For example, this is what we are using for providing SIPREC recordings, or also the media exchange module that I will present on Friday relies on this functionality to fork the media to a different destination, to a different SIP instance. So this is another cool feature that RTPProxy has. Call recording, again, can be done in RTPProxy. You can record one leg, both legs of the call, merge the two media streams together, and so forth. And you can also intercept DTMFs, currently only NTEs, so named telephone events, but probably that's 99% of the industry, right? Probably, I've never, actually I did see some audio codes, but probably no one uses it anymore because of the cost of decoding the RTP and understanding the digits inside.
Yeah, it's also unreliable if you're using some high compression codec. So if your stream is compressed with 729 or something like that, it screws up.
Yeah, that is correct. Basically, they only work with uncompressed codecs such as G711.
Totally agree, guys. And all the big ITSPs are using uncompressed just to have their minds.
Yeah. Yeah. So okay, getting back to the notifications that RTPProxy does. Well, it is able to tear down a call due to lack of RTP, and this was developed instead of using something like an emite command, such as RTP engine does. This was developed in OpenSIPS. It's actually something that I developed about 10 years ago, and was probably within my first OpenSIPS projects. The ability to receive notifications for RTP proxy timeout events. But 10 years later, almost 10 years later, almost in 2020, that's something that I modified when Maxim said November. It was November 2019. It's about 2020. 10 years later, I got engaged with Maxim to develop this DTMF detection keys feature. We basically split the work as it should have been. Max has done like 90% of the job, and I also did 10% of the job. So Max, besides developing in RTPProxy and enhancing the modules interface to be able to do packet inspection in modules. After my initial attempt of detecting RTP packets and notify OpenSIPS, he came in and did it the right job. So again, thank you, Max, for that. Also,
it was long overdue. I wanted to do it.
Thank you anyway. So. Yeah, we developed this as a new module for RTPProxy that can be found in the 2.1 DTMF branch. So there's a special branch in the RTPProxy official sources that you can download and check it out. and is also present in the master and hopefully in the new 2.2, which is going to be released soon, as Max already told us.
I already pushed the branch. So.
Oh, that's perfect. So I will have to adjust my slides. Thank you. So the fun part was that it was using the same notification mechanism. So theoretically, I shouldn't have done anything. However, there's always a however. The way that we initially developed timeout notifications in 2010 worked very simple. So when OpenSIPS instructs RTPProxy to create a call, it also gives him a token saying, hey, when this RTP times out, send me this token and I will terminate the token. Well, basically that token is exactly the identifier of the dialog, right? So when we receive the identifier of the dialog, we will have to tear down the call. Now, this wouldn't work that easy because when we got the after developing the DTMF notifications, when we got the token, we really didn't know whether it's a timeout notification or is it a DTMF. Well, we didn't know. So in order to be able to make a difference between these two events, we've modified in OpenSIPS the way that that the token is built. So instead of simply giving the dialog ID, we're saying, hey, I want a notification. The token that we build starts with a D for dialog, starts with D followed by the dialog ID. This is for a DTMF notification. You can also have T followed by the dialog ID, which is a timeout notification, which is a RTP dialog timeout. Sorry, should have been RTP timeout here. And also we have the I, which is basically ignore this notification. This is very useful when you are not interested in RTP timeout, but also DTMF notification. You would probably ask me, why am I giving you this information? It's just for you to know and to be able to easily differentiate when doing a trace or when doing encrypt, for example, between the communication of OpenSIPS and RTPProxy. You will easily be able to differentiate between the DTMFs and RTP timeouts yourself. Also, Max has built this generic interface of passing things from OpenSIPS to RTPProxy modules. So instead of giving a long line with different identifiers, which more or less at a certain point will no longer scale because it will no longer be, you will no longer be able to differentiate between whether some parameters are for modules and others are for RTPProxy core. Max already developed a way of specifying parameters to a specific module. And for this specific module, the DTMF module, we are using the AIM3 colon 1 identifier. So this, all the parameters after this identifier will be passed through the DTMF module. Some of the parameters that are needed are, for example, what is the payload type that will be used for RTP? Because you probably have noticed the telephone event, which is 101, but that's not always the same. So from your OpenSIPS script, you should be able to intercept the payload type and specify it to RTPProxy so that RTPProxy knows how to differentiate between plain RTP or other or telephone events.
Yeah, I can a little bit explain about 3:1 thing. Basically, we don't use it too much at this moment, but the way we build those modules in RTPProxy is that you can technically load the same module several times. And each time you load the module, it will instantiate one of several threads for this module. So by having the specifier, it allows us to at least technically later on scale for the modules that I'll actually need to do a lot of processing. We don't do a lot of processing for DTMF because it's pretty much, you know, you parse the RTP and there you go. But for something like transcoding or something, we want to have some mechanism where you can partition your traffic between multiple instances of the module, and you can basically scale it as you need. Sorry, Razvan, to interrupt.
Oh no, that was very helpful. To be honest, I didn't know why you used that notation, but I trust you. It was a good idea. Thanks for the explanation. Now, in terms of configuration, in OpenSIPS, you basically need to do the same thing as RTP engine. You need to specify a notify socket. This time is a TCP listener where notifications are sent to. You'll also need to specify the D flag in the offer you send to RTPProxy, because since the detection of DTMFs is controlled in OpenSIPS, you probably only want to detect DTMFs keys on specific calls. So you should only mark those calls or use the D flag only for those specific calls. And from now on, so basically this is the only thing that you have to do additional to RTP engine. After that, you still have to define an event route where for the eProxy DTMF and add the logic to handle the DTMFs. And identical with RTP engine, events can be sent further through using the event interface. So you can have your own application that intercepts those DTMF keys and do whatever you want with them. From the RTP proxy side, you will need to have a notification set. So the -n parameter, unfortunately, I forgot to put it here. And also load the module in the master branch. So starting from the master branch, you will need to load the DTMF module. But that's it. Using this more or less deep.
Just a little bit of correction. The DSO mechanism is basically, it might work for the simplest cases. I'm not 100% sure if it works for DTMF module, depending on whether or not there are some parameters in the module that you need to set, because it doesn't allow to pass any configuration parameters. So for example, if you take HEP module, for example, it takes HEP server, obviously, HEP protocol, and all those parameters. So instead of using DSO, you will need to put a configuration file.
Okay.
Those parameters in.
This is the way I used it to test, so it was working just fine. But okay, yeah, indeed, you don't really need to configure that much in DTMF, in the DTMF module. I've never used the HEP one, and there was another question that I wanted to ask you, but unfortunately there was not that much time. I will ask it afterwards. But anyway, all you have to do is load the module, specify a configuration file, as Max said, and that's it. Using this approach, you will make sure that you can use RTPProxy from multiple instances. So you are no longer bound to a single RTP, to a single OpenSIPS instance. You can use the same RTPProxy instance with different OpenSIPs, which is kind of cool. The eDTMF, eRTPProxy DTMF event has more or less the same information like RTP engine. This is not a generic notification event. So as you can see, the name is not eRTPProxy notification. It's just DTMF because you can only receive DTMF events using it. But you'll also get the digit, the duration, and volume. So these are the, you'll also get this in RTP engine. There's also one more catch, because you can receive an identifier which indicates you can bound the DTMF to a call ID or to a dialog ID. This is more or less an internal optimization, because, for example, you might have a case where you cannot create a dialogues, or you're not using OpenSIPS with dialog support. So, but you still want to get DTMF keys. So in that case, you don't have a dialog ID, but you do have a call ID. So instead of the module, instead of providing the dialog ID, which it doesn't exist if you're not using the dialog module, it will provide a call ID. And it's very hard to understand whether this ID represents a dialog ID or a call ID. So that's why we added a different switch. And also, finally, there's a stream which indicates the stream index of RTPProxy session. Basically, this indicates whether the callee or the caller has sent the DTMF. 0 is for caller and 1 is for callee. This is usual. This is the usual way it works. However, if you have like a more complex SDPs where you have multiple media streams, this will basically translate to 0 and 1 would be the caller, and 2 and 3 would be the callee. That's because you have two different. You'll have two media streams for each participant. Okay, so basically this is how it works. Let's see a couple of use cases that we've thought of or we've used. Well, one thing that you can do, and I've been asked several times how you can do that, is how you can translate inbound DTMFs to out-of-band SIP events. So as I was saying earlier, in-band DTMFs float through RTP, but some of the endpoints do not understand these in-band DTMFs, and they only work with SIP events. So you might, using this new approach, using this new DTMF notifications, you'll be able to notify OpenSIPS, and OpenSIPS will be able to send SIP events that correlate with the DTMFs. I will show you in a couple of minutes. I can also have some sort of simple setup where you have a call between A and B, and you can have a requirement if one of the parties don't input a pin within 10 seconds, let's say, then you terminate the call. I will show you in a couple of minutes how you can do that. You can also have a way of transferring a call when a specific key was pressed. So if I'm talking to, let's say, to a hospital, and the hospital says, well, you shouldn't call here, just dial *123, then I can be transferred to that extension. You can have that as well. Or, for example, you can play back a message bound to a specific key. This is the only one that I don't have a demo yet. That's because I detected the limitation in RTPProxy code in OpenSIPS, but I will soon fix it. These are the resources for my presentation. So here you can find the RTPProxy project, which I noticed Max didn't advertise on his contacts. He should have. This is the RTP engine one, so it's basically the GitHub sources. Of course, RTPProxy is also open source and available on GitHub, but I just pointed out the project site. Here you have the documentation of the two events that we have been developed in OpenSIPS 3.1, one for RTPProxy and one for RTP engine. And finally, at the beginning of the year in March, I've written a blog how to use it. So this how to use the new DTMF detection. So this presentation only complements that blog. So you can find out a lot of information in the blog as well. Okay, so let's do the demo now. Let me share, switch my screen. Sharing.
I'm having trouble containing myself. Hurry up.
I'm sharing my entire screen now. Yep, share it. Okay, I have here a console and a lesson grep. You seeing them? Hopefully. Now, this time my test call is quite simple. So I have two different phone calls. I will be using Linphone for the caller and Yolink for the callee. Let me start Linphone. We have here Alice. Let's call Bob. Answering. Okay. So now I have a call between Bob and Olna. Sorry, I hear myself twice because of the call. I need to turn it off. Actually, something else happened. Calling again. Okay, I will now press a few keys. Not sure if you hear them. Okay, the call has terminated. I will explain to you a bit later why. Okay. Okay. Not sure how to get rid of this. If anyone can help me. On the right side, I know there was a. No. Okay, let me do another test. Okay, just punch a few keys, and if you take a look to my to the zip trace, okay, just a second, I will decrease the font. Can you see my SM grep now?
Yep.
Hopefully. Okay, so what you see here is this is the call establishment, which is up until ACK, everything got established, and then I started punching a few keys on my hard phone, which were basically RTP events sent through RTPProxy, and RTPProxy intercepted them, sent them over to OpenSIPS, where OpenSIPS triggered these info messages. So I pressed here 2, then 6, no 5, 8, 4, 6. So as you can see, there's no CP info coming from the callee side. So everything flew through RTP. They were intercepted by RTPProxy, sent to OpenSIPS, and OpenSIPS send these info messages. Let me show you. Okay. Check out the DTMF. I've done some git tags here. This was what I used in order to intercept the notification and trigger the info message. So all I had to do is load the RTPProxy and event route, define the socket that RTPProxy, the socket I used to communicate with RTPProxy, and the notification socket I got the events for. engaged RTP proxy for on the invite, answered RTP proxy on the 200 OK, and define the route that handles the event. I essentially used the DLG send sequential message, which sends an info. This is the direction where it sends it, either to the caller or callee, and this is the body, the payload of the info message. However, in order to use this this function, I basically loaded the context of the dialog, and this is what has been done here. I received the dialog ID, which was present in the param ID, loaded the context, and after I sent the request, I unloaded the context. I won't get into that much details about loading and unloading the context because this is what Bogdan is going to present on Friday. But this is an example of what you can do with the load dialog context and unload dialog context messages. Because without them, I wouldn't have been in a dialog context. Therefore, I couldn't have used this function that requires a dialog context. My second demo is regarding requesting a pin within 10 seconds. Let me show you how this works. Okay, so what I've done here is when creating the dialog, I'm using the B parameter. This says send the by when the dialog terminates. I put a dialog timeout here of 10 seconds. And whenever this timeout dialog expires, trigger me this route. Here, I use this route in order to modify the behavior of the dialog. So if within these 10 seconds, I accumulated the 1, 2, 3 pin in the pin variable in the dialog, then I would have extended the dialog timeout to 2 hours. Otherwise, the dialog timeout would remain 10 seconds, and therefore the call would end. That's actually what happened in the first test call I've done. I haven't done anything, so the dialog was terminated within 10 seconds. And here in the RTPProxy DTMF route, I added some code to, I added the logic of accumulating the pin value. So all I have to do is first trigger star, and then all the digits after star will accumulate here. After these 10 seconds, if the dialog, the pin is 1, 2, 3, 4, then the call would remain active, right? So let's see how this works. Okay, let me start a new call. One, two, three. So now we'll have to wait for 10 seconds and the call will be terminated. I'm not doing anything. Okay, so the call was hung up. If we take a look at the trace, you will see that OpenSIPS generates the buy in bidirectional after exactly 10 seconds. Let's see. Okay, this is 4750, 4800. So after 10 seconds, the call was terminated. Let's try another call to Bob, where I input the calling star 1, 2, 3, 4. Okay, still going. 8 seconds, 9, 10, 11, and so on. So this was the second demo I wanted to show you.
Hey, Bogdan. Oh, sorry, Bogdan. Razvan.
Yeah.
One thing that I wanted to mention, I actually wanted to bring it earlier in some of the discussion, but keep forgetting. So I'll probably bring it up now while you're doing this. One feature that we definitely need to look at to make this functionality more useful is ability for RTPProxy to either scramble or just discard those events. Because in many of those pins bench scenarios, you probably don't want Bob to hear this pin. So it would be really interesting option for the DTMF module if you can instruct RTPProxy
to block the
either block or just put a random stuff in there instead of real events.
Actually, there is a question on Slack about this from Artur Sultan Bekov. He's asking if actually that's his second question, if RTPProxy can mute the DTMF tones when it's transcoding inbound DTMF to outbound. So basically, yeah, okay, you intercept it from the middle, but just to remove them from from the RTP stream.
So currently there's no such implementation. I know I've discussed this with Maxim, but yeah, we haven't done it yet. So of course that's why I love these discussions, because you always learn stuff from it. So yeah, we'll definitely need to do it, Max. Okay, my third demo and the last one is probably the most simplest one. So here I will make a test call, and when I hit the pound key, I will transfer the caller to SIP to Carol at summit.opensips.org, which is basically my second hard phone here on my desk. So let's see how this looks like. Okay, answering, and I need to press the pound. Okay, now Carol is ringing, answering. Hello, hello. All good. Closing. So what has happened now was I started the call here. The call transfer. So when I press the pound key, the call transfer command was run, and the river was sent to the caller. The call was put on hold, and then a new call was started from my phone to my second hard phone. Answered it, and then turned off the call. And everything it's just as simple as you can see. With only 2 lines, you could get this kind of behavior. Of course, you can have your own logic, like, for example, use pound 123 and transfer the call to 123 extension. You can do that as well. But yeah, that's as simple as it could have been. Let's see if there are any other questions. As my demos are done, my presentation is done. Let me know if I can answer any other questions now.
Yeah, I kind of commented it, but somebody asked if it works with RTP engine.
Yes. What works? So blocking the DTMFs work with RTP engine, and all the stuff that I've done works with RTP engine as well. So yeah. Okay. Follow up. Yeah, I guess there are no other. Somebody asked what kind of hard phones I'm using. I'm using a Yelink and a Snom. Probably this Snom is so old that is no longer manufactured, but it works basically with any hard phone.
Really? Do we not have any other questions?
Okay, I either was so clear or nobody is
Actually,
interested in this.
Did we answer the question? I don't know if this is a question for you.
Okay.
I'm looking at the Summit chat.
Okay.
So Arthur Sultanbekov, his first question was, is it true that every country has its own DTMF codes for in-band DTMF?
I don't think, I don't know, to be honest, but I don't think so.
No, I don't think this doesn't have to do with the countries. It's maybe the guy is mentioning what we all have seen, and Alex may have seen that also. Some providers are sending strange stuff inside your SBCs. That may be from most of the times from mobile carriers. So generally speaking, there shouldn't be any difference. Everyone should follow the protocols.
I agree.
So, there shouldn't be any difference at all. Maybe the guy who asked the question is mentioning what kind of problem. That's why he's asking. But generally, if he follows the non-compression advice, he should be fine.
He had a second part of a question too. He said, can RTPProxy mute DTMF tones when it transcodes in-band DTMF to out-band DTMF?
Yeah, we've already answered that. No, it's not currently possible, but we're looking to.
Okay, we have another question that just came on. Any recommendations for DTMF security or privacy?
As Maxim said, from our side, we should be able to either mute or modify somehow or obfuscate the DTMF codes that are being sent further. So we shouldn't pass them along, at least not for this kind of sensitive information.
Yeah, there are some scenarios perhaps where you want to keep them, and some scenarios where you don't. So I guess
He's asking, like, what method would you guys recommend for DTMF delivery when entering credit card information?
In my, I mean, this is just a perspective. I would have wanted to hear something as if the other party would type something, but I shouldn't be able to understand what he was typing. So basically obfuscating in my opinion, but this is just my personal preference.
Sharad has another question. He says, if a call is established using SRTP in RTP engine, then OpenSIPS needs TLS certificate to receive the DTMF tones, correct or incorrect?
No, because, well, when RTP engine stands between SRTP and RTP, then he must decode that traffic. So he already knows everything. So you really don't need to. He already has all the keys to decrypt the traffics.
We have another question from Mark Farmer.
Hold on, Alex. But if it's just doing pass-through, like you have SRTP flowing through the RTP engine, between the points, so without any kind of a conversion, in this case, I guess, to not have access.
Yeah, he would not have access to SRTP in this case, correct?
Okay.
So
it will not be able to extract the DTMFs.
Yeah.
Okay. Sorry, Alex. Go ahead.
Okay. Mark Farmer's question. Is there a plan to have RTP engine notify multiple OpenSIPs?
Not that I'm aware of, but I'm not the guy you should be asking this question. I mean, it's a design limitation from RTP engine, and hopefully they will soon sort it out or find a different solution.
Well, the question is, why would you need that to be done at the RTPproxy level? Because we have something, better.
RTP engine.
No,
It was on
well,
RTP
no, we
engine question.
Actually, it doesn't really matter. The whole idea, it's enough to have the DTMF indication delivered to only one OpenSIPS instance, and then you can easily use the clustering support between multiple OpenSIPS instances, and you have script functions to actually broadcast any kind of information from script level at the script level. So sorry, at the cluster level. So you can use the dedicated events in order to receive the DTMFs, from RTPProxy RTP engine, and then through the clustering you can simply broadcast this information with all the OpenSIPS instances. So that will simply work.
There's another question, whether we can do directed call pickup via DTMF. Not sure what's the scenario. So
like a call ops question, but yeah, like for instance, in a lot of like PBXs, you've got a scenario, you ringing a phone, and let's say somebody in the room wants to pick up that ringing phone, they're going to try to do a call pickup. And
okay.
I think he's talking about trying to do this up at the OpenSIPS layer rather down at the PBX layer.
Actually, the question is what the DTMF has to do with this, because at least as far as I know, I don't pretend to be a PBX expert. When you do the call pickup, you either pick up any call, you just dial a star code just to pick up inside the group, or you may dial a star codes, for the pickup service plus an extension if you want to do like a direct call pickup. But I'm not sure exactly where the DTMF will, fit in all this stuff.
Probably he is referring like inputting the pickup number after the call is being answered. I don't know.
He's right here. Unmute yourself, Vlad Payu.
No, not with his broken mic.
Vlad, hello.
Vlad, you can write it in the chat.
He did write it in the chat. That wasn't enough information for us to understand him.
Yeah, write more.
Well, no problem. We will answer him tomorrow during his presentation.
Yeah.
Nice, nice.
Okay. We should probably wrap it up as.
If we can receive the DTMF event on the script level, we should be able to do it.
Probably yes.
Well,
Yeah,
the whole idea, it's the whole, with the call pickup. When you do the pickup, it's it's more like let's say the transactional level. You don't have a call answered, because when the pickup itself is completed as action, you're already connected with the with the original caller. So the whole pickup process is done. Makes no sense to do any DTMFs after that.
It kind of feels more like an unattended transfer, I think. Maybe you can trigger that via some DTMF, I believe. Anyway, we'll clear it out tomorrow. Yeah.
That was my last demo, how to do a call attended transfer using DTMF.
Oh, there you go.
Yeah. Okay, thank you guys for paying attention. I'd be glad to discuss further in the chat room, but now Liviu has to tell us how the quality-based routing works. So good luck, Liviu.
Okay.
Thank you, Razvan. Let me
you.
turn on. Right. Congrats.
Can everyone still hear me?
Yep.
Yep, Alex is in there.
I lost my headset. Well,
Alex,
Razvan, thank you again. That was absolutely amazing. Lots of questions, lots of interest in what's going on over there. And we will have some follow-up to that and some presentations that'll be coming up. Our next speaker, well, we've seen him before. Not that we're tired of him, because he always brings us some amazing information. It's Mr. Liviu Chircu.
Chircu, come on. We can do it, Alex.
I can't make that sound with my mouth. I'm sorry.
No, it was good. It was good.
It's easy.
Kill you, kill you. There we go.
Good.
No circus. He's a very serious man. No circus.
Mr. Kill You is going to be talking about quality-based routing in OpenSIPS 3.1. So watch out, duck. You don't know what he'll be throwing at you. Liviu, take it away.
Thanks for the introduction, Alex. And as Alex was saying, this is I'm not sure whether he was saying it or not, but anyway, this is a new module that we introduced in 3.1. And the story goes back actually a few years ago, where we had an intern working for us for like almost 4 months. And he had a lot of fun with this module and spent like maybe half of his time working on, fiddling with it, getting feedback from us, and he put it together. But unfortunately, we didn't feel like the time was right for it, nor did we get any traction. So we kind of kept it into the cupboard for like little over 4 years. But this year we finally decided to dust it off and brush it up a bit. And there we go. This is what I'm going to be talking about today. If you don't know me,
what else is in that cupboard at the end of this presentation?
Maybe an OpenSIPS 2020 t-shirt. I'm not sure. Does that answer your question?
I
hope so.
Fully informed. Thank you.
Good. If you don't know me yet, I've been privileged to be with the OpenSIPS project and the ecosystem around it, and all of these amazing people that contribute and give us feedback for roughly 8 years now. And those are some handles you can use to reach out to me or follow with updates that I periodically bring from the project. And in the presentation, and it looks like my voice is cracking again, like yesterday, we are going to talk about I'm going to make a short intro on the dynamic routing module in OpenSIPS. And to those of you who are not familiar, I think it will be a great help, especially given that the quality routing extension absolutely works on top of it. So it's helpful that we have a baseline of understanding. After which, I'm going to go into how the statistics work for queue routing. How do we rate the gateways? What kind of balancing algorithms we have over there? And towards the end, there will be a fun demo. It will be interactive, and hopefully things will go well, because you never know with these kind of things, all hell can break loose, right? It can break in lots of points. So about derouting, I guess I could say a few words about its history, but I haven't researched it. It just came up. I believe it was introduced by Bogdan, but maybe I wouldn't want to give like bad information, around 2008 or something like that. So it's quite old. However, it's super powerful and has been one of the most appreciated and used OpenSIPS modules across the years. Basically, there are three core concepts there are three important concepts to it that I'm going to discuss about. First, we have the gateways, because the purpose of this module is to simply route traffic and according to what you instructed to do. And the obvious question is where to route it to, obviously to SIP gateways. And here we have an example of 3 gateways that we are going to provision into the DR gateways table. Kind of, let me put up the pointer. It's important to assign each gateway its unique ID. And here we are going to play with a gateway from a company called LOLSIP and Funcom, and the Funcom carrier, which has 2 gateways. So the discussion for derouting is going to revolve around the idea of sending our traffic or routing our prefixes to these gateways. The second concept is the carrier, which is nothing more than a grouping of gateways. We have here the Funcom carrier, which I've labeled FC, and a couple of gateways that are going to be receiving the traffic in order. So if we put, I guess this also, by default, they are used in their given order. So in this case, the first one will receive all of the traffic, and eventually, if there are any issues, for example, you get kind of error replies, the traffic will fall back to the second one. These are the algorithms that you can use. Up until now, there were either use the given order, or you could use a weight-based balancing algorithm, which I'm going to talk about in a bit. And in 3.1, we introduced, as I was saying, that the queue routing is an extension for derouting the quality-based balancing logic. So here is an example of, anyway, sorry. The third concept are the rules. So now that we have the destinations to send our traffic to, all we have to do is decide where to route each prefix. And a useful thing to mention here, or something that I overlooked, is that we had from the beginning, we had like a certain quality of these gateways. In this case, LOLSIP was a poor gateway, or kind of, we can use it as a backup, let's say, but not ideal. Whereas Funcom is the preferred player to route the traffic to. So in our example, if we have some prefixes that we want to ensure a certain baseline of quality, we would not even fail over to LS1, I guess. So we can use this kind of routing. Only send to Funcom, and otherwise don't send any traffic at all. For the and this is 44. I don't know, maybe the UK people are a bit picky, so they don't want bad media. For all other prefixes, we don't mind receiving poor media quality. So if we fail over to LS1, we'll take it. We'll happily take that. And of course, for the last routing rule, we have a Houston, Texas number, which is obviously Alex's number, and we will route it straight through LS1. So such that Alex receives less calls, since he's a busy man and he doesn't want people to bother him. We'll route all the people who want to reach Alex through the back gateway, so they hang up as soon as possible. And that pretty much sums up the prefix routing. So how we build our LCR, our least cost routing. Of course, as an operator, you will have a lot more information available, for example, which is the gateway that costs the least amount. And you can build these gateway lists to your exact preference. So you can maximize the amount of revenue, or in our case, and for today's module, we are maximizing the quality of the media. Here's an example of using the weight-based balancing algorithm. So if you look here, each identifier is assigned a weight, and the traffic will no longer have a kind of a fallback behavior. Rather, 75% of it will go to Funcom, and 1% will go to LOLSIP. This is an example of specifying the weights within a rule. But there's a next level to it as well. You can specify the weights within a carrier. So in our example, okay, 75% of the traffic goes to Funcom, but within Funcom, which has 2 gateways, we can ship 90% of the traffic to the second gateway, to Funcom 2, and 10% to Funcom 1. And I guess that's as complex as derouting gets. If all of this made sense up until now, you're pretty much 80% done with the module, and you've comprehended it. Congratulations. Of course, within a carrier, you can also sort the gateways via using quality-based algorithm, and we'll shortly get to that. So to sum up the derouting, it's a very powerful engine to build least cost routing rules. All of the prefixes are cached in RAM. This will speed up the lookups hugely compared to a disk lookup. As a fun fact, if you didn't know this, RAM is how much faster than the disk is RAM, Alex? I will tell you. Or
Why, Alex? I can tell you.
I know you know, but I want to see Alex if he knows it.
Twice as fast?
Twice as fast? Add up.
Something more.
That's a very fast disk. Send me a few of those.
It's freaking faster. You don't need to know why. It's just faster.
So RAM is 1,000,000 times faster than a hard disk drive, a memory-based one. Sorry, a magnetic hard drive.
Yeah, not an SSD one.
Yeah, of course.
Probably a little bit closer, but yeah.
Right. So the fact that all prefixes stay there, and a lot of them, OpenSIPS can take a lot of them, especially if you give it like 8 GB of shared memory, everything will fit. By the way, don't forget that you will have to use 2 times RAM, because during a reload, both data trees are still available. So there's that. We have constant prefix lookup times. This is important. And during a data reload, the traffic keeps on routing. Again, very helpful to know. So let's see the quality-based algorithm. And this is the guy who wrote it initially. This is Mihai. He's smiling back at us as well. I'm not sure. Yeah, I don't think I remember where he ended up. Probably at Google. Who knows?
If his code was in the cabinet, he's probably in a hole 6 feet under.
Yeah.
Knowing Bogan, yes.
Right. And here are the statistics that, the default statistics that the module uses in order to assess the quality of the SIP traffic. You have the average call duration, the average seizure ratio. If you don't know about this statistic, so the first one is pretty obvious, right? How many seconds a call lasts for. The seizure ratio counts how often are my calls getting answered. This is quite important because it means that if your ASR goes down, you're probably dealing with some kind of failure on your network at whatever level.
Just as quick correction, I think ASR is technically answer to seizure ratio, but yeah.
It sometimes can represent what Liviu said.
Yeah, but it's the same thing, but it's just...
Yes, seizure is the total of calls, right? Total. And it's...
seizure is
answer to seizure. So you take...
answer sizer rate.
Answers calls and divided by seizure, number of seizures.
The correct is answer sizer ratio. And even CCR, I remember in the past I was using...
Oh, yes, there's a typo in there, sorry. Answer. Yes.
And call completion radio is often called also NER, network effectiveness ratio. So it's something that I learned because I remember this names. I think I provided some input on this a few years ago.
Interesting.
So you're saying it's been 2 years and Liviu just corrected it?
No, it's been answer seizure ratio all this time. It's okay. And I think we computed correctly because we take the answered calls and divide them by the total calls. Isn't that a seizure? So
yes, it is. Anytime
anytime you make a call, it's a seizure. Whether it went complete or not.
All the others.
Yeah. Yeah, exactly. It's simple. But what I'm not 100% sure about is that CCR indeed. It's because I've looked at the code and it's kind of it's always bigger than the ASR. Let me grab the cursor again. So it's always larger than the ASR because it not only includes the 200 OK, but also the 400s, if I'm not mistaken, or the 5 or 6.
408, the unanswered, busy, and cancel. The ones that you're not, it's not your fault.
Then the code, yeah, we need to change that function a bit. But anyway, at least we have the general concept that it's it measures some kind of replies, or they're based on their SIP code, and we can add them up however the proper way to do it is, I guess. Do you have any other comments to make here, guys, on the stats, or I guess I should wrap them up. The average setup time is how many seconds? Sorry if I'm not being accurate here on the stats. I'm not sure if I recall it, whether if it's in seconds or milliseconds, but generally how long it takes to answer a call, and the PDD, how long it takes until you get something back, a ringing tone, or maybe even a rejection, I guess. Okay, so Flavia just posted the CCR. So it's 200s plus 408, 406, and 487 canceled. So a bit, so it's a superset. It's a superset of the answer seizure ratio. Okay. And the next question would be, how does the module collect these statistics? Because maybe it wouldn't be completely correct to collect them for a gateway, right, on all the routing. And the way we ended up, or the module ended up being designed, is that it collects them per prefix per gateway. And this allows you to detect maybe certain failures that are happening on some regions. For example, maybe calls to some specific country are receiving some bad stats, or anything down this line. So the module is keeping track of these pairs. Now the next question would be, how long does it keep track of these things for? And there are two configuration parameters available. There's the history span, which is given in minutes and simply says how long a given stat has left before it will expire. And there's the frequency of the sampling, or the sampling interval. And in this example, every 5 seconds, there will be the samples will basically be rotated. You can also view it as the rotation interval, right? Every 5 seconds, a set of statistics gets thrown away, while a new one gets inserted as time flows to the right. And also, and this is an awesome, how should I put it? An awesome way that open source development can work sometimes. This feature we actually received after feedback, after the initial round of discussions on the module. And if I'm not mistaken, let me see if I remember, I think Sebastian Sastre suggested, guys, we would like to see from this module the ability to route based on the media quality, or maybe the R factor, or some other stats that we may want to be able to customize into the module. And this materialized into this extra stats module parameter. And this is the syntax. Here we define the MOS, which is, if you're not familiar with MOS, I read a bit about it, so I'm not that familiar either, but at least I can tell you what it is. It's the mean opinion score of a gateway. From what I've read, that's what I'm saying, that I haven't worked with it, but it can, while it's meant to be a human opinion of a score, and it ranges from 1 to 5, where 1 is the worst score and 5 is the best, it can also be computed. So for maybe you are taking a sample of, while having the initial sample of, let's say, the best quality file, you play it through the gateway and you capture what it gives back, and then you compare the two files, and that percentage of similarity will give you the MOS, how similar is the replay of the media. Right, and the R factor, there's a bunch of ITUT documents on what it is. It's a number ranging from 50 to 100 or something like that, and it also shows the quality of that gateway. And here there are two interesting attachments you can make to a statistic. First, there's its direction, and you can use a plus or a minus in front of it. The default is plus, and it means whether you prefer it to be higher or lower. Even in our initial sample, if you haven't noticed, all operators would prefer to have as big of an ACD as possible, whereas keeping an as low of a PDD as possible. So when defining your thresholds, you have to tell OpenSIPS, okay, how do I interpret that threshold? Is it an upper or a lower threshold? Okay, and towards the right, you can also attach a custom value for the minimum amount of samples that are required for the statistic. Of course, some of them may fluctuate during live traffic, and you may want to accumulate maybe 20 or 30, maybe even 60 before saying, okay, I want to punish this gateway, or yeah, stuff like that. Okay, so we have this, we have the base statistics, we have the custom ones we can define. What do we do next? Oh, yes, and here is the script function that you can use to set these things. Because as I was saying, these are your turf. You have to fetch the data, you have to provide OpenSIPS with the MOS. For example, maybe you compute it from RTP engine, and you get it back in the script, and you set it via these extra QR set extra stat function. These are the input parameters. It's the database ID of the rule and the name of the gateway that you want to set the stat for. Remember that it's a pair, right? So we're setting not just for the gateway, we're setting that MOS, but also for the prefix. So the first one gives you the rule, the routing rule. Right. So once we have this, the next question is, how do I tell the module what is right and what is wrong? And for this, we came up with the Q routing profiles table. And this answers a couple questions. Like I said, what is exceeded and what is not, and by how much, because there are two levels of thresholds, let's say. And also what happens on each threshold, right? How does that change the traffic? And here is how it looks. Let's say we have, this is a graph for ACD. Let's say a normal value is like 2.5 minutes. And for some reason, after 20, it dips below, and not only below critical, but also, sorry, not below warning, but also below critical. So this is in the 15-second range. So probably there's some media issue going on. People aren't receiving media. That's why they are hanging up quickly, such that the average call duration of the platform has gone down so much. It signifies a critical problem here. And this is the moment in time that the gateway will probably be taken out of service. And of course, the traffic should come back to normal afterwards because it's not being used for routing anymore. And also there's what penalties do we use? This information is also included in the profile. And as I said, each statistics has 3 levels. There's a normal level where all the traffic is being sent to the gateway, and we came up with this. These are default values, of course. You can change them in the table as you wish. But we thought that maybe as a warning level, you could give it maybe half of the traffic. And if it dips below critical, okay, that gateway should not receive more than 5% of the traffic. Maybe because, of course, we have to keep on learning about its media quality. We cannot just take it out and risk, the time passing by, 60, what was that? 60 minutes. So an hour passes by, and then the stats rotate, and then the gateway is all of a sudden healthy again. So, and then more problems. So to prevent that, we just, as a proof of concept, we went with this penalty idea, such that we keep on getting feedback from the gateway. Maybe it recovers, who knows? Maybe it starts behaving well, and then the module will give it gradually more and more traffic back. And of course, once we computed these penalties for each statistics, we just multiply them together and obtain the final weight. In our case, let's say the gateway was behaving poorly with regards to answered calls, and it's kind of slow. Users get a kind of a latency before they get feedback. The PDD is down, such that the result of multiplying all of these together is a 0.25 weight. Of course, you can also set like an event for when these kind of things happen, so you can take whatever decision you may see fit. By default, this is off, but you can define this event bad destination threshold to your preferred value, such that the event queue routing bad destination is delivered via whatever mechanism you may please. Nowadays, I think there are like 6 ways for you to receive events from OpenSIPS, just to name a few. RabbitMQ, maybe via datagram, maybe via plain TCP. There's a lot. And the event will contain the prefix and rule pair that suddenly do not behave well anymore. And as far as the weights go, the last question would be, okay, so we are computing these weights for each gateway. What do we do with them? What kind of algorithm do we choose? And we chose a couple of algorithms. Actually, there was an initial one, and then we reworked it into something that we thought should be the default value, the default one. And the default one ended up being dynamic weights. So basically what we've been talking throughout the presentation, in this case, since the bottom gateway is 4 times, has a 4 times larger weight than the other one, it receives 80% of the traffic, whereas LOL-SIP only receives 1/5 of the traffic because they have poor media quality. Of course, the same thing happens if you are routing to a carrier, so grouped gateways here, the same behavior. And if a carrier has multiple gateways, the traffic is simply equally spread to them, if my memory serves me right. And this is a difference if you would have had 3 gateways. Because if we would have this scenario, whereas the other 2 ones aren't grouped, you can see that these received a bit more traffic. So if I go back to the other slide, here we had 20, 40, 40. And now with 3 individual gateways, there's this kind of spread. Just basic math, I guess, but it's kind of useful to note. Right. And the other algorithm is the one that we, you can use it if it works better for you. The gateways are simply sorted based on those ratings, and OpenSIPS uses them as a failover kind of in a failover kind of way. And this has, of course, there are some disadvantages to this approach. For example, in this case, only the first gateway is receiving the traffic, and the other ones are not being used. So if maybe if you wanted to go for a more balanced approach, that doesn't happen in this case. And there's also that problem of if a problem happens on the first gateway, of course it will be taken to the back of the list. But as soon as the stats expire or they grow old on that, and it will be taken to the top of the list, and the problem will resurface. So you have this cycle of penalizing a gateway and then promoting it back. So this might happen with this type of approach. But again, it might also be exactly what some of you want. So that's why we kept the algorithm in there.
There is solutions for that.
Yeah, exactly.
We'll talk later. I have.
Ah, okay. It's nice to keep things flexible and give users some choice. So these are some resources. There are a couple of blogs on the quality-based routing, and of course the module documentation that you can use in order to build this kind of proof of concept and play with the module and the routing. And for the demo today, we are going to perform audience-driven routing. What this means is that I've prepared, we are going to be using an OpenSIPS to equally ship traffic both to LOLSIP and Funcom. So by default, it's 50-50. And you will log into this portal here, and I will kindly ask you to do so. And we will downvote LOLSIP because they are so bad that we want to alter the traffic live and punish them using, of course, the custom module statistics that I talked about earlier. We are basically sure.
One second, just to make the people's life easier. Can you simply copy paste the portal,
right,
and put it somewhere? We
sure.
can distribute it, but typing it from the slide, it's not exactly
sure
easy.
Okay.
Or just place it anywhere
I'll put in the summit. It's in the summit chat. Right now,
cool.
it's not doing anything because the OpenSIPS is turned off. But yeah, we will play. I will show you the screen. So I put it on the summit, and I've noticed that if you put links on YouTube, they kind of delete them for you. I'm not sure. Maybe it's illegal to put links on YouTube. I'll put it there again, but I'm pretty sure.
You need approval from channel admin.
Ah, channel admin. I see. Okay, so
that would be me, but I don't know. I have not seen your links. So, yeah.
Okay.
I pasted on YouTube. So it's there.
Okay. Right. So I hope you all got this. What should I show you? I guess I'm going to go and show the screen. Present the entire screen. And go to this desktop. Can you see the website here, the curating demo? On the left side, or is it a desktop problem? I have multiple.
Yes, we can.
Yeah,
okay.
It works. Ah, perfect. Awesome. Okay. So this is all running on my local computer, and with the awesome help of Dan Jenkins, he reminded me of this ngrok.io service, which basically makes gives you a public address on their domain that points back to your private web server. So if you can see, people are already starting to play with it. And let's take a look at the OpenSIPS configuration file because there's quite a bit of time left. Routing demo. Is this big enough of a font? Should I make it bigger?
It's good.
It's okay.
It's good. Okay. And it's a very simple script. We are basically, not that very simple, but I'm going to walk you through it. Within an infinite loop, we are just going to do a hell of a lot of do routings. And if you remember the slide, this thing has constant, it's not like we have 300 million prefixes in the database to show this off, but anyway, it's really fast. And what we're going to do is here, I'm going to increment a stat with each of the selected gateways, and we are going to be looking at how they balance together after we make the changes, or after you will downvote the lolsip gateway. And this CPS will let us know how many times this thing is spinning for. You will see just how many loops the OpenSIPS can do and how powerful the configuration language is, because it's almost as fast as C. It is one level above the C coding language. It's almost, if you write OpenSIPS script, you're literally writing C code. Right. I'm not sure if this clear AVPs function is something that I made up, because the do routing leaks memory, and if you call it multiple times, you will exhaust the shared memory pool. And there we will be using this event vote. If we go here, when we receive event vote from using Razvan's new addition in 3.1, the raise event externally, you can hook into the OpenSIPS configuration via MI, which is pretty cool. So basically, when you click in the browser, you will end up in this event route. Of course, I've made here a switch so I can turn things off. I can stop the voting. And this is kind of a limitation, so you don't spam too much. And this is where we set the MOS statistic that you provide through the submit form. And this timer route, which showcases that you can iterate through an entire group of statistics, will reset the statistics every 5 seconds, such that we get fresh data constantly and know how the routing is going. Because if I had kept them accumulating, we wouldn't have noticed your impact. Then this is also worth to note here, the MOS, that we need at least 10 samples of it in order for the thing to start working. So let's start this whole thing. It started, and let's watch it. I'm going to start one. I'm going to send one message. So we start the loop. I'm going to be using Sippy. Okay, it got sent, and it's spinning right now. And it's like, if you can see, it's using up one of my CPUs fully. It's one process, like spinning like hell. If we look here, it's doing 132,000 calls of do routing per second. That is something. And if we take a look at the balancing, lolsip and Funcom, they're receiving kind of the same amount of traffic. It's pretty cool, right? 200,000, 300,000, 62. This is the reset every 5 seconds, so we get fresh data, if you notice. And that's all there is to it. Okay, so people are already submitting stuff. Okay. I'm glad you're enjoying yourselves, because I wanted to ask you, I'm not sure. Anyway, I wanted to do this on 2 levels, right? First, so I'm going to stop the OpenSIPS. Let's do the demo properly. And I'll start it, and I'll stop. I'm not sure if I have the console here. Set vote. Okay, so this. 1 second. Okay, the voting should be stopped now. So, because I knew this would happen, you would abuse of this. Yeah. I didn't tell you to submit, but who cares, right? We'll click it, of course. So my request for you guys would be, let's punish lolsip just to the first level. It's not worth looking into or I guess there is so much time. Let me increase the font here. OpenSIPS. We can look in the QR profiles table. Oh my God. Yeah. Let's do /G. Maybe it's more readable this way. It's a lot better. Okay, so if you take a look here, for your custom statistics, you just have to add these 4 columns. So these are the default ones, ASR, or yeah, in the other order. there's a warning threshold and a critical threshold, and then there's the warning penalty and the critical penalty for all 5 stats. And for your custom ones, you just add each of these warning critical, warning critical. And in our case, we are issuing a warning, or we are reducing the traffic to half whenever we go below 4.15 MOS, right? Remember, the MOS is from 1 to 5. And we are really punishing the gateway. We're just reducing it to 5% traffic whenever it dips below 3 MOS. Maybe I'm not good with the MOS. Maybe 3 is beyond unacceptable. Maybe even 3.8 is a bad MOS. I have no idea. But let's just say 3. Right, so that was, let me close this console. That was my request for you, that the first submission round is with 4 value, right? And I'm going to be, let's just tail the OpenSIPS log, and let me clear it up a bit, and let's unleash, by the way, remember, we need 10 votes from 10 individual IPs, right? So in 2 seconds, I'm going to release the voting. You guys ready? 3, 2, 1. Okay, these are the votes flowing on the left side. Oh my God. Okay, these are a lot of votes, guys. So let's see, but if, is it well, or I see a lot of, maybe something is not okay. I only see 2 IPs. Yeah, it might not be the smartest thing to use that ngrok public IP, right?
I think maybe you should purge the cache you have for the IPs, because
okay, it worked. It worked. It worked. Look, we just dipped. We don't have much time. Let me explain. We just dipped to 50% penalty, and if you can see the 2 values, it's half, right? 468 to 34. 553 to 56. It's really half of the above value. It's awesome. It is awesome. So the demo is working really fine. So up until now. Right. What I'm going to do is I'm going to stop the voting. Okay. This is using the shared variables, and I have 1 minute now until the stats clear up, so we can talk a bit about this. You can do so many cool stuff with the SHV variables. You can program your script. You can do these external hooks. You can do a lot of stuff. For example, the vote switch. So right now the voting is off, and we have to wait 1 minute for the stats to clear, and they have already cleared. If you can see, they are back to 50-50. And the CPS, funny enough, because the shared memory has been stabilizing and the fragmentation has reached a point where things don't move around that much more, we are now doing 450,000 deroutings per second. Remember, we started with 150. So OpenSIPS, it starts in a way, but then it gets better. So remember that with OpenSIPS. And its allocators, right? It keeps getting a bit better after they warm up. Right, and now I'm going to kindly ask you to punish the gateway with the ugly punishment. So we're going to give it a 2 MOS. And yeah, let's do it. I'm going to re-enable the voting, and I'm going to do the max votes. So I give you 1 more vote. So now you get an extra vote. It's max votes 2 now. And let's see if this thing works or not. I'm a bit nervous about the unique IPs. It might not be the smartest thing.
It's Windows attacking you.
Yeah, I'm not sure if it's my IP or if that thing works. It's fine? Oh, okay. Then it's good.
Out testing on it.
It's okay.
I'm just clicking like crazy. Don't worry.
Yeah, so if you can, oh, right, I forgot about the YouTube lag. So we have 1 minute. Right. So soon enough, we will start receiving votes with 2. And we should punish that gateway to okay. Oh, no, not yet. These are a lot of votes. Okay. I have a backup plan. So if this doesn't work, I'm going to send some curls locally. Okay. Maybe we can turn off maybe that thing. Averted voted. You know what? Let me give you guys a couple more votes. Now you have 4 votes. Okay, now you have 4,000 votes. Something is terribly wrong. I told you the demo gods. Why on earth? Max votes. Max votes. I'm just going to kill it. Okay. Let's just restart the whole thing. Okay, we watch it again and start the loop. And hopefully, all right, okay, good. So if we take a look, it's only receiving 1/5 of the traffic right now. It's like 1 million to 50,000, or 2 million to 10,000, 700,000 to 36. So it's only 1/20 of the other one. So that concludes the demo, guys. And thank you for all the help. You were amazing. This was awesome.
Nice job, everyone. Give yourselves a round of applause.
Awesome. I'm going to let you vote because it's, I'm not going to shut it down. Let's punish those lolsip guys because they deserve it. Awesome. The Ngrok guys are going to ban us because we are shipping so much traffic to them. Okay, so I guess that concludes the demo. Let me switch back to the slides. And thank you for all the help. And all you have to do now is go out there and play yourself with the queue routing module and let us know if it makes your life easier, if you can build cool services with it, and of course, if you can help us improve it. And yeah, thank you for your attention, and let me know if you have any questions.
Good job, Liviu.
Nice job, Liviu. Nice job.
Very good.
Nice job.
Do we have any questions here?
Yeah, there are some questions. Jonathan asking, will this be shared within a cluster in the future, or so any plans when? If so, any plans when?
This is quite deep, actually. So we would have to cluster the derouting, right? There is a certain path to this approach because right now we are synchronizing the status of the gateways. So yeah, I guess we can, but I'm not sure. There are definitely not any plans right now, but we could start making some designs for this. Yeah.
All right. Another question from Jonathan. Is QR profile stable columns customizable per custom metric?
Yes.
Yeah. Can we have multiple custom metrics?
Exactly. You can have as many of them as you want, and that was the whole thing, or how we designed the feature to allow you to put whatever stats you may find useful in there.
Okay.
I mean, we just made a stat that routes based on audience feedback. So yeah, yeah.
How do you conciliate cost and quality?
That is an excellent question, Flavio, because we've also wondered that by offering this queue routing, we are kind of making operators pick between one another, right? Do I choose cost or do I choose quality? So I don't have a good answer to that, really. you either pick one or the other. Yeah.
It's like an operations question here, and I think
yeah.
I think it depends on the destination.
But I haven't thought whether you can merge these two together right now. Maybe there is some way to build like a statistic that gives you a bit of both cost but we haven't thought about it yet. Right now it's just one or the other. Yeah.
Just like a pointing goal to the algorithm.
Yes.
You can combine those values.
Mm-hmm.
On the same quality, choose the one that costs less. If there is one that costs very less, but has a quality that is not so different, choose that one. I mean, I think that you can calculate like 2 or 3 of this combination and then choose the best one.
Yeah, that sounds perfectly reasonable.
Cost as a statistic, right? I mean, it's basically the same thing, isn't it? And as long as this is how I say it, a high cost is basically should reduce the utilization of that gateway, whereas a lower cost should increase it.
That's true.
No, I don't think that will work. The idea with the cost, if you have it, you just build the LCR, right? You just build the gateway list, A, B, C, D, and failover, so you get the most money. Giovanni made a very good point. He said we route based on quality, right? So we get this dynamic thing that assesses the quality and changes, right? But if we have this to choose between 2 equal ones, we choose the cheapest one. So that sounds pretty good. I'm not sure if I see an immediate way.
You can also pre-calculate some other things. So, for example, on the same quality, you choose the cheapest one. But if the quality is different only by, let's say, 1 unit of MOS, and the differential is more in terms of cost is more than, let's say, 15%, then choose the other one. I mean, it's all, I mean, very plain arithmetic, and this can be implemented probably more in the script than in the module.
Yeah, one idea that I have sometime about quality routing is order by cost first and have some kind of penalty. If the gateway is below a certain threshold, put in the end of the line and the end of the row. Mm-hmm. Something. If it's below, add a penalty, and then put it at the end of the line for some time, like 1 hour, 2 hours, or until you have until the gateway is on the threshold, the minimum threshold to operate, something like that. Because it's very difficult to do it online, the ordering of the gateways, because it fluctuates a little bit. Another suggestion that I have for quality routing is there's something on the registrations now where you can get the latency of the registration. I don't know if it's on the net traversal or on the mid register.
It's in the user location or not. Yeah.
It would be interesting to get the statistics of latency on the gateways too, as you can probe. This is some feedback that you could insert on the on quality routing.
I totally agree with that, Flavio. But if you have why do you have to measure yet another SIP thing, like how much it takes to do the options, when you get this whole feedback like PDD, or which one of them? Yeah, PDD. Won't that tell you how much it takes for you to route the SIP?
The PDD is more or less the time that you have to receive the first 180 or 183 or 200.
Yes,
it's not exactly latency. It's the time to complete the call. Let's suppose you have let's suppose a gateway using a R2 connection that it's usually slow, 7 seconds to receive the digits.
It's not the same thing. Yeah,
it's not the same thing.
Yes, because the 180 maybe comes from the endpoint, the final endpoint, right? Yeah, whereas the latency, you just measure it with the gateway, correct?
Yeah.
So
we have something like a threshold for latency. Okay, put the gateway out after some threshold, because it's something very reliable in terms of when a gateway starts to get bad, the latency usually gets bad very quickly.
Something that, I mean, it's not, one thing's for sure, there's different points of view on how to do this, but this discussion's been all about the operator side, and what's being left out is the consumer side, or who you're selling to, because they're willing to, at a certain price point, they're willing to deal with a somewhat not good gateway, let's say, and that's how a lot of the providers, especially here in the US, will sell their their packages. Okay, what do you want? High quality, high cost, or do you want low quality, low cost?
That's correct. I think your point of view is correct.
So determining what your customers' thresholds are on top of what your own makes it even more complex.
Oh, it's a business decision, I guess. There is some question from John Farmer. He is asking, can you limit the ranking? Get away will receive never take less than 20% of the calls, for example.
Yeah, that's a good question. The direct answer is no, but I'm going to clarify what he's referring to. I told you that the penalties multiply together, right? So for example, if 3 statistics of 50% are multiplied together, that's like already only 12% of traffic. So Mark is saying, okay, can we have like a base limit so this multiplication doesn't make it 0? Yeah, and there is no limit right now. It can go to 0.
Yeah. Oh, cool. Well, a lot of questions. I guess, I don't know, you guys want to continue with this, or do you want to take it offline with Liviu? I actually have two notes on the presentation, which I wanted to inject. So if you don't mind.
That's abuse, Max. You're abusing your position.
Yeah, but once in a while. If you can go maybe to the slide 21.
So 1 second. So if we all agree, I mean, we can allocate like 10 more minutes. I mean, people can wait for their prices 10 more minutes, right?
Okay.
Wow. Executive decision.
Exactly. It's a business decision here.
We will win them anyway, so who cares?
Oh my God. Yeah.
What's the next show after us?
Raffle.
So Liviu, can you do slide 21?
Okay. 1 second. Present. Right here.
Yeah, 21, maybe 20, or yeah, 21 is okay. So I think what you are dealing here a little bit, and it also was mentioned on slide 30, particularly when you're talking about gateway going in and out kind of repeatedly. It's very important, and it's something we discovered probably a few years ago. I mean, 2010, maybe 11, 12. Whenever you happen to use like feedback mechanism to do some kind of dynamic control, I put a little drive in here. Let's see if I can share it. That's my slide. Window.
Do you want me to turn off the sharing?
Oh, it will take over, I think.
Okay. Full abuse.
Yeah, sorry. So you have basically.
Wow, that is very technical.
So you have the situation which is called control loop. And that's basically what you're trying to do, right? So you basically have some kind of control mechanism which could do something. Let's say throttle this stuff up, and then you have some kind of measuring thing which controls the result and feeds back into control. It's a very known problem, and basically, if you implement it just like this, you always will end up with some kind of constant oscillations on the control channel, because there is a delay between you applying the control in here and then it taking effect in on this, and then there is some delay measuring it. So you will always be like playing catch up with that thing. Now how it's dealt in general is that you apply. Let me share. You basically apply filtering between your measuring apparatus and the control apparatus, which is basically. What's that?
Zoom in a little.
Zoom. Okay.
This is good.
So you basically apply. Oops, smaller. I'm just showing as a electric circuit, but it could be just an algorithm which removes like high frequency component from your feedback signal, and then what happens, instead of that kind of always jumping up and down, you will end up with some initial kind of rollout when it settles, and then it basically finds the sweet spot which kind of balances it all.
Okay, this is awesome.
Yeah, I'll
but
send you some links. Yes.
I have a question for you. Are my slides visible?
Not yet, but you can.
Not yet. Sure.
Oh, I have to. Sorry, let's resume. Blah blah blah.
Yes, once he wiped you out, he completely wiped you out.
Right. So if we go to how should I put this? The simple fact that we are not excluding the poor gateway out of the loop, doesn't it mean that we keep on getting the feedback out of it, and that as long as it doesn't go
no, but you're starting sending let's say let's go back to the simpler scheme where you have one gateway, maybe that's slide number 30, when you have one gateway which kind of goes through cycles. I mean, the fact that not only you're measuring different amount of traffic, but also you're trying to kind of fix this gateway, right? Let's say it has some capacity limit which starts to kick in at some point. Yes. Every gateway does, right? Whatever limit that might be, it could be on signaling, or it could be on database, could be on network. Sooner or later, you'll hit this limit if you put enough traffic on it. So by the fact that you're applying this control and starting sending traffic elsewhere, you kind of fix it. So from being bad, it goes into good. Absolutely. So you're starting having this oscillation. So you basically.
I'm not, Maxim, I'm not advocating for this algorithm, by the way. This is why we didn't make it the default. but I'm thinking, but maybe even with this one, right? Even with dynamic, it's the same thing, maybe.
It's the same thing. That's what I'm saying. Because effectively, you're removing load from that gateway, right? It could be removing completely, or you might remove like 50% of the load, and eventually it will.
And then it's fixed, right? So you go to the same cycle. Yeah.
Exactly. That's one point. Another thing that I wanted to mention, I would really interested to look at your number lookup routines, and the reason for that, we built a little private module. We never really publish it anywhere, and we call it DNC daemon, and it's basically designed to take literally millions numbers and allow a very quick lookup among those numbers. And also it allows the reloading, the same things that you mentioned. So I was curious if we could, maybe your algorithm is better than ours. Maybe ours is better. It would be interesting to see if we can share some knowledge.
I can answer that quickly for you. The derouting module is basically using a tree structure. It's not a tree, Alex, like the one you pick up peers from. It's a TRIE tree. Or I'm sorry, do I pronounce it poorly? Is it? I don't think it's try. I think it's tree.
No, you're doing good.
I've never heard of that word before.
Yeah, I understand what you're talking about.
Yeah, tree. Yeah, so we're just using a tree, a huge tree. Yeah, like millions of hundreds of millions of prefixes, and the lookup time is constant.
Well, that would be interesting to compare. Like load the same amount into your code, into our code, and see what could be better. We don't mind releasing it as open source. It's just we never really saw any cool application for it outside of our domain, but so it seems like very interesting problem that people are working, and yeah, very interesting presentation in general.
I'm glad you liked it.
Sounds like he wants to
not
race
only me,
you,
like everyone.
Yeah, it was great. I'm happy the demo went well.
We do have some more questions, but we are about 10 minutes over.
Yeah.
So in order to continue in either direction, we're going to need another executive decision. Ah, look at him. You need me.
Let me share the Slack.
Yeah, I think we can. We should go with the raffle, and
let's do it.
We can continue the discussion here, or we can take it to the Slack after that. It's up to the people.
So I just want to let everybody know that once again, another night has gone by, and we've reworked the AI for the picker. Yesterday's release was a little, well, I don't know how to put it, shady at best.
Alex, I have to say that indeed there was a flaw, because it should have picked Liviu also the second time. So we worked out this flaw. So this time it will be the first, the second, and at least the third attempt will be all the time Liviu.
This is
hijack.
Great.
Yeah.
This is great. We're going to be here for another 20 minutes just trying to give away a t-shirt. Oh, by the way, just so everybody knows, what we are giving away is this amazing OpenSIPS 2020 Summit t-shirt. Up till now, they've only been available to moderators and prize winners. This is your chance. Remember, you must be inside of the channel. That's the Summit Raffle channel, and answer if we manage to pluck a name out that doesn't belong to us. Liviu, looks like you've got the Live AI warmed up here.
It's warmed up. Yep.
All right, let's get those wheels spinning.
All right, 3, 2. Oh wow!
Wow.
Wait, let's confirm. He's here.
He's typing.
He's here.
Yeah, great job.
Welcome. Congratulations.
Now that we've given away the most insignificant prize in our raffle today, for 1 hour of unadulterated time with the core OpenSIPS team, where you'll be able to flash your ideas, and that's it, just your ideas. We have a contract that you'll be signing in accepting your prize. You will.
Thanks God, everything is online remotely, right?
Yeah, thank God for you. No one knows even if you're wearing pants over there.
Well,
No,
that's
stop.
the question of the night.
I will assure everybody that Bogdan will be wearing pants during your 1 hour session with them. So, looks like we have a killer Live AI. He's about to choose today's grand prize.
It's working well tonight. Let's do it.
Liviu, you better knock out some wood really fast.
It's gonna be a good one, I'm pretty sure. Mustafa Ildrim. The confirmation, and there we go. Congratulations.
Oh, nice. Congratulations. Well, ladies and gentlemen, that's going to bring us to the end of our third day in the summit. Just to let you know, that means there's only 2 more. Am I correct?
Well, conference-wise speaking, yes, but keep in mind that next week on Monday, same time we have the workshops with SIP Capture Hober, with CG Rates, with Janus, and of course with OpenSIPS doing DFKS stuff. So we have 4 interesting workshops. In the same time, Maxim will organize and run the OpenSIPIt. So will be a lot of testing for different projects, and I think that will be streamed, and probably Maxim may provide more information if anyone wants to interact or to, I don't know, participate, contribute.
Yes.
And yeah, so the OpenSIPIt will be Monday and Tuesday, and for the people who also register for the training, for the OpenSIPS training, that will be on Tuesday. So yeah, there will be after that two more days. But the conference part will end on Friday.
Wow, don't be so sad now. What you just described to us for next week seems pretty damn exciting.
Definitely it will be.
Awesome. So like I said, we're halfway through basically at this point, folks. Thank you to all of our speakers, all of our moderators today. Again, to Maksym, Sobolyev for making this possible to be broadcast all over the world. Good job to everybody. Round of applause for another day in the books.
Great.
And most of all, thank you to all of the community, who's taken time to put eyes on these presentations, to interact with us and ask really interesting questions. That's really what made the day amazing today, is your interaction with us. So keep it up. We look forward to seeing you over the next 2 days. Bye, everyone.
Bye, everyone.
Bye. Have a good rest of the day.
Yeah.
Ciao.